Next, we have an exciting topic lined up for you. Our second speaker, who will join us just about in a minute, is Andrii Boichuk, AI Technical Leader at Blackthorn AI. Andrii will be sharing his expertise on how AI can enhance medical image processing, bringing about cost reduction, process optimization, unbiased AI diagnosis, and much more.
Hello, everyone. I hope you can hear me just fine. So before we start, let me just answer a few questions I saw in the chat before the talk. I saw some questions about sharing the previous presentation. Unfortunately, due to Amazon's strict policies, we can't do that. And we did our best to try to share them, but unfortunately, that's not possible at the moment. But that's not the case for my presentation, and this one will be shared after the conference. So again, hello, my name is Andrii. I'm AI Technical Leader at Blackthorn.ai, and I'll talk about how to improve medical image processing using AI. So let's start with the definition. What's medical imaging? And that's probably something you faced a lot of times in real life. It's basically ultrasound, MRI images, mammograms. Everything that can be presented as an image, but in medical domain, can be put into this category of medical imaging. So what's the problem with it? Well, first one is accessibility. With medical imaging, it's usually a lot of times a costly procedure. You have to pay quite a substantial sum. And there is also lack of doctors to read them, to interpret your images. Only 1 in 2 women in US get their mammogram read, according to Stanford Medicine. Second one is interpretation. Training and education of radiologists takes a lot of time and money. And what's more, there is like a huge gap between some radiologist who just started their career and someone who has been in the field for 20 plus years. And we just can't wait 20 years when we need twice the radiologist at the moment. And image reading consistency. Humans make mistakes due to fatigue, some other issues, maybe some problems at home just happened to be at the same time as you have to like get your mammogram read, or maybe you have your ultrasound interpreted. At the same time, there are also problems doctors are facing. Bad image quality, missed area of concern. Like, let's go one by one. Bad image quality. Let's say you just got your ultrasound, and then you go to the doctor. Hey, please explain what's here. Am I healthy? Am I or am I not? And the answer may vary, but a lot of times the problems lies that you might not even get an answer and have to do the same imaging procedure again. And that's a huge problem because, especially with high Q, you'll have to wait like a month to redo your imaging. And this is really critical, especially when we talk about cancer and terminal diseases. Another one is missed area of concern. Well, we can do them in a batch, yes. So bad image quality and missed area of concern. Third one is multiple modalities. It's hard to interpret ultrasound and mammograms of the same region. Like, for example, if you want to analyze breast ultrasound and breast mammograms, which is needed a lot of times to make sure that patient is healthy. And it's hard to combine them. And final, there are a lot of images. To make this problem with multiple modalities even harder, you can have like 4 images with mammograms and more than 100 for ultrasound. And to match them to understand that, hey, this one region on mammogram is displayed here in ultrasound, it's quite a challenging task. Also, there are problems clinics are facing. Radiologists are getting increased patient return ratio. So they have to go again and again to see the same doctor, to ask some questions, to make additional imaging, etc. Misdiagnosed patients suffer from false positive biopsy tissue damage. And you can think that this is not a huge problem because, hey, at least you are healthy. But if you think about it, don't know about you, but I don't really like when someone takes samples from my skin, and the biopsy is even more painful. And this highly impacts patient satisfaction. Inconsistent radiologist performance. As I already mentioned, radiologists can just have a bad day. Long diagnosis process. You'll have to, in order to get diagnosed, you'll have to a lot of times get ultrasound imaging, which means you'll have to wait like a week if you're lucky to get ultrasound done. Then get mammogram done, again, might be another week, maybe 2, maybe even a month in some cases. Then you have to go to your radiologist, ask, hey, what's the spot here? Am I healthy? Am I not? And maybe you'll have to go back to additional imaging. And when you count all this time a patient has spent in a clinic, it will amount to 2, 3, even 4, maybe in some rare cases, half a year time from first imaging to the diagnosis. And lack of highly experienced doctors. As I already told you, there is like huge gap between novices and expert radiologists, which means that experts are very rare. You'll have to wait, again, 10, 20 years to get from novices to expert, and a lot of times we just can't wait so long. But before we continue, let me just spend a minute and talk about who I am. As I already told you, I'm AI technical leader at Blackthorn. I have over a decade of experience in IT, ranging from small projects to projects for global Fortune 500 companies. I worked with various partners, including some from global Fortune 500 and also FANG, which is Facebook, Amazon, Apple, Netflix, Google. And I'm also teaching machine learning in university. Here you can get my credentials. If you want, feel free to connect with me in LinkedIn or mainly on my mail address. I'll just wait if you want to screenshot this slide and get a super photo. Okay, let's move. And how do we solve all those problems? There are a lot of possible solutions, but one of the solutions I personally worked on and directed was to create an AI imaging diagnosis solution, which will take in patient images and diagnose them, interpret them, and moreover, it will be seamlessly integrated into clinic diagnosis process. This is first page which you'll face when you get to our solution. If you can see that here's like some charts with detected lesions, there's some analysis in progress, and recommendations of what you should do after you've got your images analyzed. And let's just go through quick workflow of solution. You can get your images uploaded here. After they finished, you'll get, you can start analysis. And in this screen, you can see that analysis is in progress. And when it completes, you'll get this sleek and small, easy to interpret table with the results. And as we can see, left breast LCC and LMO has a normal, but we detected some benign regions in the right breast. And as you can see, it's not just right breast, it's right breast in both projections. So from the side and from the top. Sorry, I think there are some problems with the presentation. One moment. Let me just click through it. All right. Sorry, presentation wasn't updated. Yeah, and after you got your results, you're able to view them in this like view, mammogram view, we call it. And moreover, you are not just able to like view them, you can interpret them. You don't get just the result that this is breast is benign or this breast is cancerous, malignant. You also can see that there are some regions and what are them? What are they? And also on top of it, you get a heat map. And this heat map explains, hey, this region is highly suspicious. I haven't detected, it's not suspicious enough to be classified as benign or malignant tissue. But at the same time, out of all of the breast, this region is the most suspicious. And same can be seen in this on the bottom image. Again, that was mammogram. This is ultrasound, right? And you could get, hey, I saw this ultrasound image, and on the left you can see there are like a lot of malignant parts. And the truth is that almost on each ultrasound image you see here, there is a malignant tissue. For me personally, this sounds like a highly suspicious case. And I, as a patient, can do appropriate actions. Maybe I'll have to speed up my diagnosis. Maybe I can go to additional images, and I don't even have to wait for doctors to diagnose me. I can already do some steps in advance to make sure I will be healthy. And as a result, you'll get like this mammograms, part of images, and ultrasound. You'll get huge list with all your medical images analyzed. No, but that doesn't look like a seamless integration, right? Because when you have to go get your images, download them yourself as a patient, it's like additional steps you have to do. But that's just one option of integration. Another one is to do a seamless integration with the clinic. And here you can see how it can be done. So this is a slide from RSNA conference, and it just shows a great and simple way to integrate it into clinical diagnosis process. So when you get, first, let's start with EHR. You get an order to do some imaging, right? So patient comes to you and you see, hey, let's put it to EHR, let's fill order, and let's follow to the image taking, to modality, what's called here. It's why it's modality, because there are like different images, right? Ultrasound, mammogram, MRI, CT scans, X-ray, etc. After that, as usual, all of those taken images will be sent to image server. In USA and in Canada, you are required to have them, and you always send them to image server to collect them. And when they are sent to image server, this is the step in which we can integrate AI solution. We can say, hey, new image has come, let's analyze it. And that's what is done. You can go, AI orchestrator detects that there is new image and sends it to the specific AI algorithm used to integrate this solution into clinic workflow. AI algorithm do the processing, makes their magic done, and then results are sent back to image server. And what's nice about all of it is there is no extra human interaction. When doctor starts to read the exam, he just sees, hey, there is like raw images and there is AI part. Let me just open one here, and I can read them seamlessly. Even more, I can not just read them seamlessly, I can even prioritize which parts, which images should be read first. After that, there may be done some additional steps regarding AI image interpretation, AI image results analyzing, but it's more about improving current AI solution and less about integrating the existing one. And the huge advantage of the solution is that you don't have to actually upgrade your image taking device. You don't have to switch from some Samsung ultrasound to the newer model. You can just use your old and high quality devices and integrate AI part without updating, without spending extra money. And how did we do it? This is an architecture of the solution. We did this with Azure. This is a cloud solution, but with this architecture, it actually can be deployed locally as well. And as long as you have HIPAA compliance, everything should work and will work for you. So what are the results for this specific project or for this specific solution? As a result, we developed a solution which performs better than average radiologist. So remember when I told you that there is a huge gap with novice and expert radiologists. And we are not just beating novices, we are beating even somewhat experienced radiologists. Of course, they're like humans which have spent 20 years in it, and there's probably no way you will beat them soon. But at the same time, that might be even not our goal, because just by acting as an average radiologist, we will be able to improve the quality of decision made even by expert radiologists. You know the saying, you even sometimes need a rubber duck to talk to have to make a better decision. And AI can become this rubber duck to make sure that even expert radiologist doesn't do mistakes. We integrated this solution into the telemedicine solution. So I'm sure you have faced at least once in your time with telemedicine solutions when you can interact with doctors in your country or worldwide and ask them for diagnosis, for some kind of advice, etc. And what's more, in some of them today, you can even ask for AI for opinion. And we are also in the process of onboarding radiologists to the platform. This is a long process because you have to do a lot of culture fitting. You'll have to do a lot of AI education, but we've started it and in the process. So overall, how can healthcare benefit from AI imaging? First one is combination of AI radiologist, of AI and radiologist to make a better decision. The impact is huge. Scientific papers say that even with bad AI, you'll improve the quality of decision almost by 25%. We can speed up reading of highly suspicious mammograms and ultrasound images. So imagine that you have a bunch of images, right? A bunch of patients. And probably some of them are normal images. So normal meaning they don't have any suspicions, being suspicious of cancer. And at the same time, you can operate that, hey, maybe I'll have to read images of highly suspicious cases first. And if you can allow to do that, that might be a good idea to make sure that speed of diagnosis for patients which are likely to have cancer is as small as possible. And third one, you can provide AI explanation to the patient without distracting the radiologist. I just show you this heat map, which can show the suspicious regions, but that's just one part of it. You can actually even use current generative AI to build on top of it and to explain this image as text, or maybe even as voice. Yeah? And this hugely closes the gap between expert AI users and just novices. Maybe just my mom will be able to use AI solution to read her images and make sure that she's healthy. And to end this all, I'm sure you'll have some questions about, is my organization, is my company ready to implement AI? And as we already told you, you get AI readiness checklist. This is just a small version of it. But let's quickly go through it one by one. What types, how can you check if you are ready for the AI and if you can implement it in your company? Data preparedness. This is first one. AI always starts with data. And yes, there are like huge models called foundational models, which don't have to be trained sometimes, but you still have to evaluate, you still have to know how good this solution actually is. And in order to know it, you'll have to need data. So what about data? Data. You might want to audit all data sources and assess access methods, which means that you'll have to make sure your data is protected, and you'll have to make sure that there is no like bad agent which can fake your data, make it gone, etc. Quality. Ensure high quality, consistent data. This is hard one, I know. Data always evolves, business processes always changes, but at the same time, if you can, I'd say that this is probably one of the most important checklists, one of the most important points I want to make. If you just remember, forget everything and remember just one thing from all this AI readiness checklist, make sure that you have a high quality data and it's collected consistently. And address gaps and clean this data if needed. Governance. establish policies for privacy, security, and compliance. Infrastructure, ensure scalable infrastructure considering cloud solutions. And as you saw, this is one of the reasons why we went with cloud solution, because the scalability of it just allows us to process huge amounts of data, and at the same time making sure we are Azure and HIPAA compliance. Same can be done with AWS, as you just saw it, and with Google Cloud, with GCP. And via signing specific agreements, we make sure that our PHI, personal health information data, will be safe. Next one, infrastructure preparedness. You want to make sure that you have compute power, scalability, integration, and security. This one probably isn't as important as previous part. And this is usually done when you start working on AI. But if you can do some steps in this direction, I'll advise you to do them as soon as possible. Culture preparedness. This is a hard one. You'll have to, and there are like a lot of points why it's hard. Let's just go one by one. Leadership, secure top management commitment, and funding. AI can be done quickly. You can have first results in a couple of months, but the commitment should be long-term. Literacy, promote AI understanding across all employees. This is hard, and what I even would say is that today some of the healthcare providers have in their policy not to use ChatGPT or similar solutions to make a diagnosis. It goes to the point when ChatGPT is just banned, right? And can be accessed in the clinic. This is a radical solution, but at the same time, it's sometimes needed to make sure that doctors respond for their solutions, that doctors take responsibility for their diagnosis. Change management. Prepare for workflow changes and potential resistance. When you want to integrate AI, there will be changes made into your business processes and made into your maybe whole clinic operation or whole company operation processes. And innovation, encouraging experimentation and learning from failures you'll highly benefit from it. And if I come back to this solution I've just told you about my AI imaging diagnosis solution, if you listen carefully, I said that radiologists are in the process of onboarding to the platform. And this just shows that culture preparedness is a slow process, and you have to start slowly and share your thoughts about AI, share that we'll have to be prepared for AI in coming years today. And strategic preparedness. Use cases. Define problems AI will solve or may be able to solve, focusing on high-value cases. Like, don't just focus on, hey, I want to diagnose this image, and focus more on high level. I want to speed up radiologist workflow. While they are similar and can be done at the same time, they have a slight difference, which will make a huge difference in the end. Talent. Identify skill gaps, train staff, and hire AI experts. This obviously, AI changes every day. It might be hard to get a hang of it and to make sure that your solution you have in your mind is a valid one and will benefit you if you're not an expert in AI. So identifying skill gaps and what kind of talent you might need also will be helpful. Ethics. Develop guidelines for ethical AI use. As I already told you, in some companies, in some clinics, in some healthcare providers, ChatGPT is banned, but it goes beyond ChatGPT. Even with AI imaging solution, you still have to prepare and make sure that each of your personnel knows of AI guidance, knows how to use this AI solution, and to which degree you have to agree with it, and to which degree you can trust it. And ROI set clear ROI expectation and success metrics. If you'll have problems with any of the steps, just write me in LinkedIn. Maybe I'll be able to help. And continuous learning. It's not enough just to implement AI. You will also have to continuously improve it. You have to learn from feedback, implement continuous feedback to improve AI. Moreover, when you talk about something that patients are not used to, you'll have to think about how to manage expectations, how to make sure that patients understand what is done if your AI solution will be exposed to patients. Stay informed. Keep up with new AI technologies and practices. For example, I spend every day at least 1 hour reading scientific papers, and this helps me to stay informed in AI field. Partnerships. Form partnerships to accelerate AI initiatives. It's not enough if you want to have a solution quickly, if you want to integrate it quickly, it's usually helpful to have some kind of partner which has an expertise with it. Yeah, and that's all. But to sum it up, AI can help not just to diagnose images, it can help even not giving a strict diagnosis, it can help radiologists by improving their performance, it can help patients by interpreting their results, and it can help clinics by improving speed of diagnosis, by by increasing amount of patients which have done readings by mammograms or ultrasound images, etc. Thank you. Now I think we have some time for questions. Do we have some?
Yes, I think we do, Andrii. Thank you for that comprehensive and enlightening presentation. We'll move on to the Q&A session. Please submit your question in the chat if you haven't submitted already. The first question, I believe, is how is responsible to do the ETL process to so specialized data like the healthcare's data in their platform? If you can answer that, Andrii, that'll be great.
Yeah. Let me just rephrase it a bit. How to manage ETL data responsibly, and how to probably make sure that you are compliant with all the regulations and that your data doesn't get leaked. So, compliance. As I told you already, Azure, AWS, Google Cloud, all of them are HIPAA compliant. So as long as you use them, it's allowed to use them. But there are also a lot of steps which you have to follow to stay compliant. Like you have not to send data to your partners which don't need it. You have to have business association agreement signed. And you have to make sure that you not just protect your data, but also report on data breaches. And about data breaches, let's go to security. With security, there are like huge list what can be done, but at a minimum, as a minimum, there are like there are some third-party solutions which will not just check that your solution are HIPAA compliant, it will also check that it's secure and no data breaches can be done easily. Some of them include things like DOS protection, so your website or your solution won't be down. Another check that SQL injections won't be done, and as a result, you won't get patient data leaked. I hope I answered it.
Thank you. We also have two more questions. The next one is, what prerequisites are needed to develop an AI-based medical imaging system, and how and can such systems be built without the resources of FANG companies?
Yeah, great question. Let me think just a moment. Yes, those systems can be built without hundreds of billions of dollars, but obviously there is a difference. And difference is main difference lies in two ways. First one is these big companies usually focus on big general solutions, meaning that they might not cover your specific use case, right? So let's say, for example, same ChatGPT, Gemini from Google, 𝐊𝐞𝐲 from Anthropic, etc. All of them are some foundational models. They're good at conversation, at conversing their thoughts, but they're not good at diagnosing images. And from what we experience with this project, it's already, you don't have to have like thousands of billions of dollars to make a good solution which fits your needs. But what will you have to have is a mind that this will help me and help my patients, and probably good AI experts to do that. So to summarize, first one, focus. Big companies don't have this huge focus. Second one is integration. You can actually somewhat integrate and tune up these huge solutions made by fan companies and tune them up for your specific use case and use them.
Thank you for your answer. Yeah, we also have another question. Is how can AI help minimize doctors' errors and contribute to safer patient care? If you can answer that as well, it would be great.
Yeah, great questions. I love them just because that's some things I wanted to share with you, but thought I might not get into time. So, can you read it again?
Yeah, sure. How can AI help minimize doctors' errors and contribute to safer patient care?
Yeah. So first one, as with this medical imaging solution, you can, for example, before even going with images to radiologists or to ultrasound experts, you can run these images through a AI medical imaging diagnosis system and filter which images are more suspicious. First. Second, after radiologist or after some another doctor have diagnosed the solution, you can again check that this solution matches with AI, or even more, matching is just not enough. Maybe you'll want to make sure that radiologist, for example, has marked same suspicious regions as your AI system did. And these two ways to make pre-processing, right? Before visiting the doctor runs through AI, and after doctor diagnosed your images to run through AI, just these two steps will help to drastically improve the quality of diagnosis, and scientific studies confirms this. And for example, if you have reading by one radiologist, you'll have around 80% quality of the diagnosis. If you have your solution, if you have your image read by two radiologists, you'll get it up to 95%. And if you have this read by an AI, you'll get over 90%, just an AI. But what if you combine AI and radiologist, then you can get to the two radiologists. So you can get a much higher quality of results, much higher quality of diagnosis without spending the time to wait for a second radiologist to read your image. Mikhailo?
Yes, thank you very much. And we have one more question. Can you provide examples of how AI has optimized process in clinics to enhance efficiency?
Yes. Let me just think about which of the cases I can share with you. Yeah. So I think Alex, our next speaker, will be talking about it. But one of the cases is information extraction from patient documents. I will not spoil it, but I think it will be helpful to see the presentation, to see that lecture. But out of it, another one would be automatically processing of scanned documents. And what we did with it, we had there are a lot of documents which are scanned in the clinic, and not all of them are easy to interpret. So you can use AI solutions, convert them to AI readable format, and process them and understand that, hey, this document is for patient Andrii, this document is for his wife Oля, etc. And after you process them, you can already do some decisions like book a meeting, book a visit, and maybe analyze some images of theirs.
Thank you. Thank you also for your questions.